Let's start coding out our merge sort algorithm. As I mentioned in the previous video, our algorithm will be comprised of two separate functions. One is a function called merge sort, which takes in a single array as a parameter. And our second function is called merge, which takes in two sorted arrays, array 1 and array 2, as parameters. Let's start building out our merge sort function. For now, all that we want to do in this function is split the array R into two halves, so we are left with two arrays of equal or about equal length. So we will say variable middle index equals R dot length divided by 2, all wrapped in a math.floor. And we will say variable first half equals R dot slice from 0 to the middle index, and variable second half equals R dot slice from the middle index all the way to the end of the array, which is simply written like this. Great, so we now have two arrays, first half and second half. We also want to handle for the case in which our array passed in only has 0 or 1 elements. We know that if our initial array only has 0 or 1 elements, then it is already sorted. So up here we will say if r.length is less than 2, we want to return r. Great. And that is where we are going to leave our merge sort function for now. We will come back and finish it up after we work on our merge function. So our merge function is going to take in two sorted arrays. And this is where the merging that we talked about in the introduction video takes place. We are going to be repeatedly comparing the first elements of each array and moving the element of lesser value into a final array each time until all of the elements from both arrays are in the final resulting array. So the first thing that we want to do inside of our function is define our final array, which we will call result. So we will say variable result equals an empty array. Next, we want to define a while loop, which is where the meat of our merging will take place. So we will say while array1 dot length and array2 dot length, which pretty much says while neither of these arrays are empty, we want to run this while loop. So inside this while loop, we are going to compare the first element of each array and move the lesser one into our result array. So first we are going to define a variable called min_elem. Next we are going to say if array1 at position 0 is less than array2 at position 0, then we want our min_elem to equal array1 dot shift. This dot shift method essentially pulls the first element out of our array1 and sets our min_elem variable equal to the element that was pulled out. Next we will say else, which here means if the first element in array 2 is less than or equal to the first element in array 1. Then we want to set our min_elem variable equal to array2.shift. So now our min elem will be set equal to whichever first element of our two arrays is lesser. Also, at this point, because we use the dot shift method, the minimum first element has been removed from the array it was taken from. Great. So the last thing we need to do inside of our while loop is push the min elem into our result array. So we will say result.push min elem. Okay, cool. So now once our while loop has finished, we will have our result array filled up with most of the elements from our initial two arrays, and they will be sorted in the correct order. Now, at this point, we also know that one of our arrays will have at least one element left in it, right? Because when we compare our first elements for the last time in our while loop, one of the arrays will become empty when we take the min elem out of it, and the other array will have that final element in it still. And since one of our arrays will be empty, our while loop will no longer run. Also, imagine if we had these two arrays inside of our while loop. Our whole left array would be emptied out, but our right array would not even change at all, because all of the elements in the left array are lesser than all of the elements in the right array. So after our while loop has finished, we will definitely be left with one empty array and one array that has at least one or multiple elements left in it. So now we need to add the remaining elements of that array to our result array. So we will say if array1 dot length, or if array1 is not empty, therefore it is the one that still has some elements left in it. If array1 has length, then we want to do result equals result.concat array1. This will simply add whatever is left in array1 onto the end of our result array and return to us a new array. That is why we have to write result equals this part right here, because the concat method does not alter the array that it is placed on. Instead, it connects the two arrays and returns a new combined array. And in this statement, we are rewriting our result array and saving our new combined array in that variable. This also keeps everything sorted correctly too, because we know that all of the elements in array 2 would be of greater value than all of the elements that were in our result array. Cool. So next we want to say else, or if array 1 does not have length, then we know that it is array 2 that has length, or some elements left over in it. Else, we will do result equals result.concat array2. Great. And finally, we want to return our result array. And that is our merge function. At this point, it should correctly merge together two sorted arrays into one large sorted array. Great. Now let's head back up to our merge sort function. So right now, this function takes in a single unsorted array and splits it in half into two separate arrays. We now have to use some recursion to make these functions work together properly. So we have our base case up here, which says that if the length of the array is less than 2, we simply want to return that array because we know that an array of length 0 or 1 is already sorted. And all of this below our first line is our recursive case. Even though we are not using an explicit else block here to define our recursive case, we are using an implicit else block, which basically means that we will only reach the code below our first line if our if statement up here is not satisfied. If this if statement is satisfied, then we will never reach the code below it because we have this return statement right here that would run. And whenever a return statement runs, it breaks out of the function on that current line. So, long story short, merge sort is going to be a recursive function for us, where this if statement is our base case, and the rest of the code below it will be our recursive case. For our final line of code to finish off this algorithm, we are going to write return merge sort the first half, and merge sort the second half. And this is where our recursion comes into play. And our merge sort algorithm is done. This recursion right here is kind of crazy looking, right? And a little confusing. Well, don't worry. In the next video, we are going to use a diagram and an example to run through exactly what is happening in this algorithm. See you in the next video.